guys. So in this topic we are going to study about the TC cycle. Okay, in my previous video I told you the complete picture of the what is glycolysis and how it is important. Okay, now in this reaction, I just want to give you some brief about how I told you about the glycolysis, how it occurred, and how the step 1, 3, 6, 7, and 10 are important. 1, 3, and 10 are the regulatory step. All of these things I discussed in my previous lecture. So in the glycolysis, we got the pyruvate from the glucose. Okay, now this pyruvate go to the mitochondria. Okay, this reaction, whole reaction, it occur in the cytosol. When pyruvate is produced, it go to the mitochondria, and then further reaction occur here. Okay, in the mitochondria, in the first reaction in which the pyruvate is converted into acetyl CoA, this reaction is done with the help of enzyme which is called the pyruvate dehydrogenase. Okay, dehydrogenase. So this pyruvate dehydrogenase, it is not a simple enzyme, it is a complex. This reaction which seems to be like in single step, it is not a single step. Okay, it is done in which is done under the three enzyme. Okay, so which enzyme are present in this complex pyruvate dehydrogenase complex? It has enzyme which are three in number. Okay, which three enzyme are present here? Okay, so first enzyme which is present here, this enzyme is called simple the pyruvate dehydrogenase itself. Then the second enzyme which is present in pyruvate dehydrogenase complex is called dihydrolipyl trans-acetylase. This is the second enzyme, and the third enzyme is dihydrolipyl, okay, dehydrogenase. So we have three enzymes in the pyruvate dehydrogenase complex. One, pyruvate dehydrogenase itself, then dihydrolipyl trans-acetylase, and dihydrolipyl dehydrogenase. Okay, you just need to remember these enzymes. Okay, these are the enzyme in this reaction. What are coenzyme? Okay, this complex has enzyme and coenzyme. Okay, there are three enzymes which I told you. Okay, and then we have 5 coenzyme in this reaction. You only need to remember which coenzyme are present. Okay, you don't need to get in the whole mechanism how this occur. Okay, you just need that this pyruvate dehydrogenase consists of 3 enzyme and 5 coenzyme. Which 5 coenzyme are present? First is TPP, which is called thiamine pyrophosphate, which is vitamin B1. Okay, then we have then we have lipoic acid. Okay, lipoic acid. Then the third one we have CoA. We have CoA. CoA is pentathonic acid. Okay, vitamin B5 is this is the active form of vitamin B5. Okay, and then we have 4 FAD. Okay, FAD or FADH. Okay, then at the last 5 number coenzyme is called NAD positive or NADH. Okay, so these are the 5 coenzymes which are present in the pyruvate dehydrogenase complex, and these are 3 enzymes. Okay, this complex help in the conversion of pyruvate to acetyl CoA. Okay, you don't need to remember the reaction, you just need to remember these enzyme and coenzyme. Okay, so in this reaction, whenever you have a dehydrogenase enzyme, okay, in the dehydrogenase enzyme always there is a production of NADH. Okay, you should remember that whenever you have a dehydrogenase enzyme, it means it is enzyme which cause the hydrogen to leave in this reaction. When pyruvate is converted into acetyl CoA, a hydrogen is released, and this hydrogen is taken up by NAD. Okay, NAD positive, and it become NADH. Okay, by getting this hydrogen. Okay, so in every reaction when you have a dehydrogenase enzyme, there will be a production of NADH, or sometimes it will produce the FADH. Okay, so in TC cycle I will tell you the reaction in which FADH is produced. Okay, So this is the first step which occur in the mitochondria. Then we have the cycle which is called the TCA cycle. So this reaction, the first reaction, is not present in the TCA cycle. Okay, so TCA cycle is you think you can see this reaction has a lot of intermediate. So don't worry, I have a mnemonic for how to remember these intermediate. Okay, so first in this reaction, acetyl CoA is converted into state, but with the help of oxaloacetate. So when acetyl CoA combined with oxaloacetate, it forms the state. Okay, so how can we remember these enzymes? We have a mnemonic which is oh, can I keep some sugar for myself? It means yes, can please can I keep some sugar for myself to so that I can use it later. So you can say that O. Here the O is for oxaloacetate, then C for straight, I for alpha, I for isostate, and K. This K for ketoglutarate, alpha ketoglutarate. Okay, this is very important, alpha ketoglutarate. I tell you why. I used to say alpha ketoglutarate as it is king. King is like kg. Okay, king, we say king like kg. So this is very important. So this is a king intermediate. Okay, so kg, why it is important, I'll tell you later. Okay, so S for succinyl CoA, then second S for succinate, F for fumarate, and myself M for malate, and then we again have oxaloacetate. So this mnemonic will help you in remembering this whole cycle. Okay, so in this cycle you should know why we need this cycle. We need this cycle when we degrade the glucose and we get the pyruvate. So if further degradation of pyruvate produce this cycle. Okay, and we get NADH and FADH in this reaction, and 1 ATP is also we get from this reaction. Okay, so let's do this cycle. This is very easy. We just need to remember the enzyme are very easy. You just need to remember that this in the first step there is a production of state. So first enzyme is a state synthase. Okay, state synthase. Okay, then in the second reaction in which the state is converted to isostate, this reaction is very simple. Its enzyme is isomerase. Some books write it aconitase, but we simply say it is isomerase. Okay, so Kg, I was saying that Kg is very important. Why Kg is important? Because in the reaction before and after the Kg produce NADH. So here the NADH is produced, NAD is converted into NADH, and here again in the reaction before and after the Kg we have NADH production. Okay, and you know in the previous lecture of the glycolysis I told you the NADH, one NADH gives 3 ATP. Okay, so here the NADH is produced, and in the when the Kg converted to succinyl CoA, again NADH is produced. Okay, so I told you in this step when there is a dehydrogenase enzyme, NADH is produced. So there should be the enzyme which has the name dehydrogenase. So this enzyme is called isostate dehydrogenase. Very simple. And this enzyme is called alpha ketoglutarate dehydrogenase. Very simple. Whenever you have NADH production or FADH production, you can simply name dehydrogenase enzyme. Okay, so in the next step, when succinyl CoA is converted into succinate, okay, here this reaction is also important. Why? Because here the GDP is converted into GTP, and this GTP is then again is converted into ATP. So for your convenience I just write like this. Okay, so it means that this step, when isostate converted alpha ketoglutarate and then this converted to succinyl CoA, this reaction gives NADH. And in the previous lecture I told you that when NADH is produced in any reaction, this reaction when this NADH go to electron transport chain and there it produces the 3 ATP. So it means in these reactions ATP are not formed directly. So these will be the oxidative phosphorylation which produce the ATP. Okay, And this reaction in which the succinyl CoA is converted into succinate, this reaction is very important because in this reaction ATP is directly produced. ATP or GTP are the same thing, very little difference. Okay, so in any reaction when GTP or ATP is directly produced in the reaction by any substrate, this reaction is called substrate level phosphorylation. Okay, in the previous lecture I also told this thing, and this is again repeated. Okay, so there is an enzyme which has this reaction which is very important, which is called thiokinase. Thiokinase, you simply know this enzyme thiokinase. Which thiokinase? Succinyl CoA thiokinase. Okay, so you can simply know that this is the thiokinase which is involved. Okay, so dehydrogenase, to dehydrogenase, then we have thiokinase. And this reaction in which the succinate is converted into fumarate. So whenever you have fumarate, your mind can tell you that there should be the production of FADH. So F for fumarate and F for FADH. So here is FADH production, FADH from the FAD. Okay, it means hydrogen is added, so there should be dehydrogenase enzyme, which I told you before. Whenever there is production of NADH or FAD, there should be a dehydrogenase enzyme. So enzyme is simply dehydrogenase. Which dehydrogenase? Succinate, because there is a dehydrogenation of succinate which produce the fumarate, and this FADH is formed. Okay, so succinate dehydrogenase enzyme is here. Okay, then the last, this reaction is simply fumarate is converted to malate. Fumarase enzyme is present, you don't need to remember. Okay, then malate when converted into oxaloacetate, there is again production of NADH. So there is a lot of production of NADH. This is the reason why this TC cycle is very important. Okay, NADH production, and we know there when there is a production of NADH, enzyme is very good, dehydrogenase. So their enzyme is called malate dehydrogenase. Okay, malate dehydrogenase. Okay, so this is very easy. You simply know the substrate which intermediate which are involved in this reaction. Then another step are very easy. You simply know there is a dehydrogenase enzyme which produce the NADH or FADH, and there are a lot of dehydrogenase in this. Two dehydrogenase enzyme are before and after the Kg, and one is malate when converted into oxaloacetate produce NADH. So we have 3 NADH, and 1 NADH is equal to 3 ATP. So 3 NADH are present. Okay, so we have 3 NADH. We can write how many ATP are produced. We have 3 NADH, and we know that 3 and NADH is present into is equal to 3 ATP. So 3 multiply 3 ATP, we have 9 ATP from NADH. We have 1 FADH. And FADH is equal to 2 ATP. So 2 ATP multiplied 1 is equal to 2 ATP. Okay, and we have 1 ATP direct, which is substrate level phosphorylation. Okay, 1 GTP, which is equal to 1 ATP. So totally we have 12 ATP in the TC cycle. Okay, so we have 12 ATP. So this question can be asked in the MCQ: how many ATP are formed in the TC cycle? We have answered 12 ATP. And which of the following intermediate produce this 12 ATP? This. Look, acetyl CoA is added in this reaction and whole step occur, and this oxaloacetate is used, and again it is formed. So in the net, acetyl CoA is the intermediate which produce these 12 ATP. So acetyl CoA or the TCA cycle both give 12 ATP. Okay, this is very famous question which is mostly asked in the MCQs. Okay, then this some reaction is also in which step the NADH is produced. So in this step, before and after the Kg, and when malate is converted into oxaloacetate, NADH is produced, and when succinate is converted into fumarate, you can simply know that F for FADH production. So this reaction produces FADH, and this is also sometimes asked in the MCQ that in which reaction of the TCA cycle there is a substrate level phosphorylation. So when succinyl CoA is converted into succinate, there is a production of direct ATP or GTP, which is called the substrate level phosphorylation. Okay, so here the one thing you should know, that there are two reactions in which the carbon dioxide is produced. Okay, this Kg, why I was saying that Kg is very important, because Kg produce in the step before and after the Kg produce NADH, and this is also important that step before and after the Kg produce carbon dioxide. Okay, so this is also asked how many carbon dioxide molecule are produced, 2 molecule of carbon dioxide. How many NADH, you know, 3 NADH. And how many FADH, 1 FADH and 1 GTP. Okay, so this is the whole TCA cycle we just completed by knowing this regulation. So whenever you are asked about the regulation, you simply, they are asking about which molecule or which hormone help in the in this reaction to occur, and which hormones or which chemical stop or inhibit this cycle, okay, or this reaction. So regulation, when we have calcium ions, okay, this is very important, calcium ion or ADP, it means ADP means we have low energy. So when we have low energy, we degrade this pyruvate to get ATP and NADH, which further give 3 ATP. So when ADP are present, it tells that body has less amount of ATP. Okay, when we have less ATP, we do this TCA cycle to get more ATP. Okay, so these are called the activator of this reaction. And water inhibitor, look, when we have already NADH or ATP, we don't need any NADH and ATP, because we have lot of amount of NADH and ATP. So our body try to not try that this reaction will not occur, this reaction should not occur. Why? Because we already have NADH and ATP, we don't need any ATP and NADH. So these reaction are, these two things cause this reaction not to occur. Okay, because in this reaction is done due because we need ATP and NADH. If these are already present, these will block this reaction. Okay, so this TCA cycle is complete here, and in next video we will cover the glycogen synthesis and degradation, by which we will complete our almost carbohydrate metabolism. Thank you.